sweet and precious students today. My computer just glitched, so that might be weird, but whatever. I don't know how to edit videos, sorry. So you just get a straight shot of me teaching you. Today we're gonna talk about real numbers, yes. So if you're joining me today, I also wanna say I am proud of you because you're supposed to be starting algebra in your next semester, whether that's the fall or the spring, and you're practicing. That is delightful. This will help you immensely. So what we're gonna talk about today are real numbers. And you're probably asking yourself, if there are real numbers, Caitlin, are there fake numbers? There are, and we call them complex, AKA imaginary numbers. And we will talk about those when you hit Algebra 2. Algebra 2. So remember that. So right now we're just talking about real numbers, not any non-real numbers. And so today, what I want you to do is pause the video, draw this guy out. You don't have to do the non-real if you don't want to, because we're going to talk about this, and you're going to want to memorize these. So how does this work? All right, well, we're going to talk about first all the way down here. This is, we can classify all numbers, and either, so once we've established that numbers are real, they are either rational or irrational. Some rational numbers have even further complex delineations that we can put in there, okay? So let's talk about real numbers, rational and irrational. Guys, rational, look at this, rational, look at this lovely word in here, ratio, a ratio. Quick reminder, a ratio is just a fraction. It's a thing comparing another thing. And when we talk about it in fractions, we say it's part over whole, a thing comparing another. So fractions, basically, if you have a real number and you can turn it into a fraction, then it is a rational number. Things like 0.3 with a line over it. From my first video, you better remember that this is 1/3. That can be turned into a ratio, therefore it is a rational number. So decimals that repeat, those are definitely rational. 0.25, this is a decimal that terminates. Well, 25 is 25 over 100, right? Which we know is 1/4. That can be written as a ratio, therefore that is a rational number. So I'm gonna put these in here. 0.3 with a line over it, 0.25, any fraction. All fractions are rational numbers. All fractions. As long as they don't have a radical in it that can't be reduced. So I should probably put a caveat on that. Most fractions are gonna be rational numbers. Okay, so the next one is gonna be irrational numbers. So we've talked about rational, things that cannot be written as a fraction. My favorite one, you guys probably remember this from like 4th grade when you started learning about circles, is pi. That's that 3.1415, blah, blah. They've looked and it's got like a million digits behind the decimal and it never repeats. That is an irrational number. Things like this, square root of 9, in my last video, I told you to learn your perfect squares, so you better know that. Square root of 9 we know is 3. 3 can be written as a ratio. Kablam, I just wrote it as a ratio, so therefore square root of 9, 3, those are all rational numbers. Irrational, square root of 7. That is not a perfect square, and if we do that, oh, sorry about that, guys. I had to reach for my calculator. Square root of 7, if you take a look here, square root of 7 equals blah, blah, blah. That actually goes on and on and on, and it doesn't repeat. So the square root of 7 would be considered irrational. Now that you know what the difference between rational and irrational is, in the rational column, we actually still have things that we can further compartmentalize these down to. Think of it like a big umbrella and then little. And when we're classifying numbers, we want to go to the smallest one we can. So we're going to start with this. Counting numbers, they're also called natural numbers. So I switch between the two terms. Counting and natural means the same thing. Counting numbers means things you use to count. 1, 2, 3, so on and so forth. 1, 2, 3, ... Those are our counting numbers. Now, whole numbers includes all those counting numbers, but one other one, 0, because we don't use that one for counting. 1, 2, 3. So 0 is a whole number. Now, and it includes all these counting numbers. That's why that box is like enveloped in there. Integers, those include all these whole numbers, 0, 1, 2, blah, blah, blah. But it also includes their opposites, meaning the opposite of 1 is -1. The opposite of 2 is -2, and so on and so forth, okay? It does not include things like 2.5 or -2.5. That would be rational, but it is not an integer, okay? So let's practice these guys right here. Now that you have these all written down, because I know you do, we're gonna practice, and I'm gonna take them off the screen. All right, let's look at this one first. Negative 15. We know that that is a rational number because it can be written as a ratio. Bam, just wrote it as a ratio. Kablam. Same with this guy right here, right? We know that, so when we go into our rational, yes, we know that it is an integer. Is it a whole number? No, because it's got that negative. So integer is the best one we can use to classify that. Integer. Same with this negative 22. Integer. 6/17. Remember what I said about fractions? All fractions are rational numbers. So this is rational. Now, we know it's rational, but is it an integer, whole, or counting number? Nope, because it is a fraction. This guy, this is a decimal that repeats. It's going to be 0.18181818. That can be written as a fraction. It is 0.18 over 99. When it repeats like that, you do 99 instead of 100. I just wrote it as a ratio. Oh, wait, why did I put a decimal there? That was dumb. It's 18 over 99. I don't know. But now I just wrote it as a ratio, right? It's not reduced, but don't worry about it. So we know it's rational, right? But it's a fraction, and so it's not any of these other ones. It's not integer, whole, or counting. Square root of 95. If you don't have a calculator in front of you, let me do that for you. Square root of 95. Take a look here. Kablam. 9.7 blah, blah, blah. 9.7467. It's not repeating that I can tell. So it's non-repeating decimal. It can't be written as a fraction. So this is what I was thinking about earlier. It can be written as a fraction, like I could put that over 1 and it's the same thing, but that doesn't count. So if you've got a square root in there and it's not a perfect square, it is irrational. And once we decide something is irrational, we don't have to figure anything else out. 8. Yes, that is rational, but it's not just rational. It's also an integer, but it's not just an integer. It is a whole number, but it's not just a whole number. It's also a counting number. We can use it to count. 8. So this is a counting number. You would get it wrong in my class if you put like rational, because it's more than just a rational number. Give it its full proper title. 0 divided by 8. That, friends, is just 0. And what is 0? It is definitely rational because we can write it as a fraction. It's definitely an integer, but it's also a whole number. That's that special one that is a whole number. The only time you should have whole number down is if it's 0. 12 divided by 6, that you always want to reduce these before you establish what kind of number it is. That's 2. That is a rational number because it can be written as a fraction over 1. So it's not only a rational number, is it an integer, whole, or counting number? Well, it's definitely an integer, it's definitely a whole number, and it's also a counting number. It's something we can use to count. Bam. Fraction cannot be reduced to anything else, so it is rational. Rational. Square root of 7 minus square root of 7 we know is 0, and the only time we can use whole numbers is when it's 0. Whole number. 18 divided by 3 equals 6. We know that that is definitely rational. It can be written as a fraction. It was written as a fraction. And so it's rational, but it's also a counting number. Counting number. So hopefully that clarified what those real rational, irrational numbers are. And then next year when you're in Algebra 2, can't wait to introduce you to fake numbers. Yay! If you have any questions, leave them down below. Otherwise, thank you so much for tuning in today, and I look forward to seeing you next time. Bye, guys.